staph bacteria is being studied along Hawaii Island shores. On October 3rd, the County Council Environmental Management Committee heard a presentation on rainfall-driven shifts in Staphylococcus bacteria in Hilo Bay, where reports of infection seem to be on the rise.
Aloha, everyone. My name is Louise Economy, and I am a graduate student at the University of Hawaii at Hilo in the Tropical Conservation Biology and Environmental Science program. And I'm here to present our research entitled Rainfall-Driven Shifts in Staphylococcus aureus in Hilo Bay, Hawaii. I'd like to acknowledge my advisor, Dr. Tracy Wigner, also my committee members, Dr. John Awaya with the Biology Department at UH Hilo, and Dr. Aaron Strauch, a researcher at UH Manoa and manager for the Commission of Water Resources Management. I'd also like to acknowledge the funders for this research, which is the Hau'oli Maoloa Foundation and the Pacific Island Climate Science Center. So to begin, I just wanted to give a brief background on what staph is. Staphylococcus aureus, or staph, is an opportunistic pathogenic bacteria, meaning that given the right conditions, it can cause disease. It can invade wounds and cause boils, rashes, and even flesh-eating disease. It is also known to enter the system and cause blood, heart, and bone infections, though these latter infections are associated with hospital settings. Staph infections are treated with antibiotics. However, the widespread use of antibiotics has led to the evolution of strains that are resistant, including methicillin-resistant Staphylococcus aureus, or MRSA. And staph and MRSA infections are becoming more and more common in the community and affecting people that are previously healthy. A suggested spot for these infections in the community are recreational waters, including beaches. Staph and MRSA has been found in beach water and sands across the United States, including in Florida, Washington, California, and Hawaii. And there has been documented associations with health risks, as a study done on Oahu found that beachgoers were 4 times as likely to develop Staph aureus skin infections compared to people that do not go to the beach. The main idea for how this staph enters the water is removal from human skin. Someone goes into the water and they have staph on their skin, and this staph is then washed off and pushed into these water systems. And this makes sense because it's known that actually 2 out of 5 people have staph on their skin at any given time. So if you look around this room, every 5 people, 2 of you guys might have staph on your skin. And these people don't have infections. They can just be carriers of the bacteria. And so this could be a problem when you go into the water with lots of friends and you're sharing your bacteria to these water systems. And then when someone else comes in with an open wound, they can be exposed to this bacteria and it can cause an infection. So though removal from human skin has been thought to be the main source of staph in recreational waters, there is evidence suggesting that this bacteria is present on the landscape. On Oahu, staph was found in 19 out of 22 streams across the island. And this is suggesting that this bacteria can persist on the land. And if it can persist on the land, this suggests that it can be moved into our ocean waters through rainfall, through Mauka to Makai connections, and this could be a potential health threat for our ocean users. So to look at this problem, our research aimed to look at 2 main questions. How does rainfall and streamflow influence Staphylococcus aureus in coastal waters? Are there relationships? And if there are, what are they? And the second is, where does Staphylococcus aureus exist within the watershed? And to answer these questions, we're conducting a study here in Hilo on the east and windward side of the big island of Hawaii. Hilo is known for its rain. Ku papu Hilo I Ka'ua. Hilo stands directly in the path of the rain. Hilo has one of the highest precipitation rates in the United States, and is known for its variable rain patterns and frequent rain pulses. In this map, you can see that we have two main rivers entering into Hilo Bay. We have the Wailuku River and the Wailoa River. This map also shows the 4 stations from which we collected our samples. We have a station here in Reeds Bay. Here, I'll point to it on the map, just to orient you guys a little bit. We have Reeds Bay here, the Wailoa River Mouth Station, the Wailuku River Station, and the Hilo Bay Water Quality Buoy Station. We also took water samples from upstream of the Wailuku River. At each of these stations, we collected water to process for bacterial analysis, and we also recorded basic water quality parameters. During each sampling event, we recorded river flow data from the USGS Streamflow gauge, and we collected rainfall data from the Hilo Airport rainfall gauge and the Pi'ihonua rainfall gauge. When we collected the water, we filtered it and we plated it on a media type selective for staph. We then restreaked the staph and used the restreaks to confirm coloration. And we subjected a subset of these restreaks to additional testing, including coagulase tests, gram staining tests, and we have saved a few for future genetic analyses. And here is our results. On the bottom, or x-axis, we have the log of rainfall. So this is cumulative rainfall in the 24 hours prior to sampling. And on the y-axis, the vertical axis, we have the log of Staphylococcus aureus in concentrations of colony-forming units per 100 milliliters. And we can see that first we have data from the Wailoa River Mouth Station in blue and the Reeds Bay Station in black. And we can see that we have significant and positive relationships for both of these stations, suggesting that when we get more rain, we're getting more staph in the bay. So that was data from the Wailoa River and the Reeds Bay Station with rainfall data collected from the Hilo Airport. And just here's a map to show you the relative locations. And we did an additional analysis with the Wailuku River Station with rainfall data from the Pi'ihonua rainfall gauge. And here is the analysis from that. Again, we have the log of rainfall on the X on the bottom axis, and then the concentration of the staph on the Y. And again, you can see that we have a significant and positive relationship showing that staph does increase with heavy rainfall. So when we get these higher rainfall, we can also get increased stream flow. And increased stream flow can expedite the transport of pathogens from the land to the bay. And so we wanted to see if we did see a relationship between staph and stream flow at the Wailuku River Mouth Station. And this graph shows the maximum stream flow on the x-axis. So this is the highest the stream flow gauge got 24 hours prior to sampling compared to staph in concentrations of colony forming units per 100 mils on the y. And you can see, again, we have a significant and positive relationship suggesting that higher stream flow does lead to increased staph concentrations within Hilo Bay. And if you know the Wailuku River, you know that the Wailuku River can get pretty high. Stream flow can increase, and it can increase by orders of magnitude. It can also increase pretty quickly. And this led to our second question, which is, are staph concentrations impacted by these unstable conditions in the river? And this graph aims to start to answer that question. On the x-axis, we have the log of flow compared to the flow for the 7 days prior to sampling. So this is the stream flow on the day we sampled over the stream flow for the week prior. So this is telling us if we sampled on a relatively wet day compared to the week before, that would be values closer to 1 on the graph. Or if we sampled on a dry day with low flow, following a week of pretty stable, heavier flow. And this graph shows that we sampled during a range of those conditions, and as you can see in values closer to 1, we're getting higher concentrations of Staphylococcus aureus, meaning that on those wet days that follow a week of relatively dry stream flow, we are getting that pulse. We're getting a push of staph from the landscape into the bay and increasing concentrations of this bacteria. So we saw that rainfall and streamflow impacted staph in Hilo Bay, and we wanted to look directly to see if we could find staph upstream, up the river. So we collected a water sample 245 meters in elevation up in the Wailuku River, and we found, yes, we did see staph upstream. This graph shows staph concentrations on the y-axis and values from the mouth, and then upstream. The black bar, if you guys can see the black bar, is the median value, and it's flanked by the upper and lower quartiles. At the mouth, we're getting a median value of about 83, and upstream, we're getting a median value of about 30. There is not a significant difference between the mouth and the upstream of the river. However, we do see more variability at the mouth, suggesting that this bacteria could be influenced by more factors, and this variability could also be due to mixing with ocean water. So we found staph upstream, and we wanted to look more specifically at locations within the watershed and within the landscape where we could identify staph. The literature says that they have found staph in soil. It's been found in soil around pig farms, and it was able to persist for the whole year, throughout the whole year. Staph has been found in sands across the U.S., also in wastewater from wastewater treatment plants, and in urban runoff. So we started to look at these sources, and we did find staph in soil. This past summer, we did a project with a pipes intern, Tyler Gherkin, and the goal of this project was to see if we could find a difference in staph concentrations in plots that were ungulate-free, pig-free, they were fenced, versus plots that weren't completely fenced and therefore had some intrusion of ungulates. We did not see a significant difference in staph concentrations between the two plot types. However, what I think that is important from this is we are seeing staph even within forest soils at ranges between 0 and 1 colony forming unit per gram. So this is suggesting that if we're getting erosion and we're getting soil moving into our water systems, that they could be carrying staph into our water. So next we looked at sands, and we've been conducting a study with Melia Takakusagi and Carmen Garcin Shumway, both interns, and they have been looking at sands across Hilo, at Honolulu, at Bayfront, at Onekaka, and at Richardson's. And here you can see that we do find staph at each of these beaches, ranging from 0 to about 7 colony forming units per gram of sand. And Melia is going to be continuing this research throughout the year, so we're looking forward to finding more information as she continues. So next we wanted to look at wastewater in urban runoff, and so we collected a sample of wastewater from the Hilo wastewater treatment plant, and you can see in that picture we have the dirty looking bottle, that's the influent, and the cleaner looking bottle, that's the effluent, that's the stuff that came out. We only collected one sample, but we found very high values in both bottles, between 4,000 and 5,000 colony forming units. I would like to say that the effluent in this sample was just chlorinated, so usually as it moves to the ocean, it's undergoing further decontamination processes, so these numbers are very likely drastically lower by the time they make it through the outfall. But this does tell us that there is staph in our wastewater, and if our wastewater is leaking into the environment, it can be carrying these pathogens. We also took a sample from road runoff in downtown Hilo, and we found even higher values of staph within that one sample, about 9,500 colony forming units. And this was similar to what other studies in urban environments have found, that road runup has these really high numbers of bacteria. And this makes sense because it's picking up all the bacteria on the road, on animals, on cars, on people. If someone spits on the road, all of that is getting washed. off, and all of that is going straight into our water systems where people can be exposed to these pathogens. So basically, what all of this is telling us is that staph is pretty present on the landscape. It's present on our watershed. And if we get rain is going to wash that straight into our coastal waters, and that could potentially have health threats for our people that use our beaches. So to recap, we saw that high rainfall and streamflow leads to increased staph concentrations in coastal waters, and that we think that the landscape is one likely source of staph to our coastal water systems. Additionally, a thought we had was that climate change could influence Staph aureus loading to coastal waters, because we're seeing that those heavy streamflow events lead to magnified staph concentrations in the bay, and predictions for Hawaii are suggesting drier days with more frequent and intense rainstorms. During these storms, we could even have a magnified risk of health issues and water quality impairment in Hilo Bay. And with that, I would like to say thank you for inviting us to share today, and I'd like to thank everyone who contributed to this project, and I'd be happy to take your thoughts and questions. Mahalo.
Just a couple of things. I'm intrigued by the work you've been doing. These things aren't numbered as far as page, but the where it says Staph aureus is present in forest soils. On there you have a graph where it says ungulate versus ungulate free. Am I reading this correctly, where there's more bacteria in ungulate free?
That is correct. However, there is no significant difference because the ranges overlap.
Mm-hmm.
So, and if you look at the values, they're between 0 and 1, so they are pretty low.
Yeah.
And we did have a small sample size, which could also have led to this, but there's no difference between
no
our
statistical
plots.
difference.
Yeah.
Okay. With your, I'm going to use the term bloom of staph in the bay. When did you sample after a rain episode? Is it immediate? Is it 24 hours, 48 hours?
We would sample in the morning at all times. We'd always sample at sunrise. And then as far as looking at a rain event, we would see from that time of sampling 24 hours prior, and we'd add up the rain, or we would look for the peak streamflow within the 24 hours prior to sampling. So that's just a blanket number for the 24 hours prior to sampling. We didn't sample specifically like 6 hours after we saw a peak on the hydrograph.
Have you looked at trying to sample hourly or every 2 hours during a rain episode? Because staph, you get into your logarithmic growth very quickly. And have you considered that part of your increase might be a growth response to nutrition being more available, bacterial growth? I'm intrigued by this.
Yeah, so we have definitely thought about that. The thing, first of all, it's very hard for us to sample hourly because there's so much work that goes into these samples.
But you understand my question on
right,
that.
so
okay.
It could be due to just added nutrients into the bay, and that's spiking the growth of staph. I have talked about this with Dr. Strauch, and he said that though that might be a thing to consider, we see that when we do sample upstream, we're finding the staph. When we do sample on the landscape, we are finding staph, suggesting that it is moving downstream. Another thing to consider is that when these bacteria go into the environment, the sun also impacts them. Mm-hmm. And so as they persist, they should be reducing in number, not increasing.
The other thing that we've noticed is that
I'm sorry, Tracy, can you please just say your name?
Sure. I'm Tracy Wigner from Hilo Marine Science Department. One of the other things that we do know from previous work is that the bay flushes out pretty quick following storm events, so that water isn't stagnating in the bay. We find that within 3 or less days after it stops raining, that the water becomes clear again. So there's like a big, when the rivers are discharging very high, it's actually pushing a lot of the water in the bay out as like a big water mass. And so it's not necessarily sitting there allowing for the bacteria to multiply. They might be multiplying in the water mass, but that water mass is being transported offshore because the river flow is so high that it's pushing all that water in the bay out.
How long will the bacteria live in salt water?
One study I found said that the bacteria will only last for 2 hours. However, other studies have suggested that certain strains can resist heat shock and they can persist in non-reproducing states for long periods of time, over weeks.
Okay, thank you. I have lots of questions, but I'll yield.
Mr. Kanuha.
I know the studies were based off of the rainfall and the waters, but, and I hope there's some studies about, the Kona side, because we've been getting a lot of people calling into my office about their kids getting staph at the beaches. And I know a few members from the Environmental Commission have actually come and talked to us about that as well, the increase in the amount of people that have been getting these infections. And we don't have the rivers, we don't have the rainfall. It's just something that I really would love to see, and hopefully we have those stats. I have no idea if anybody has done a lot of these studies on that particular case, but because it is a growing concern, whether it's within the sand, I don't know, it's just something that I hope you guys can consider, and I would love to see those stats or studies on it. But really interesting to see, and I hope we continue this conversation, not only on this specific topic, or not only on the rainfall and the rivers and how it increases the amount of staph inside these areas, but I had no idea that 2 in 5 of us have it on us all the time, and I heard that, or one of the things that people told us was, when you go to the beach, just shower before you go into the water and shower when you come out of the water, and of course the cuts, try to avoid going into the ocean. But I mean, we have so many people, especially on the west side, using our beaches, that of course these things are going to increase, but really want to get the public educated on what we can do to decrease these infections, if there is that way, that method. But I don't really have any specific questions. I just want to thank you.
Hi, this is Tracy Wigner. We have, most of our research to date has focused on the Hilo side because we were interested in the connection with rainfall.
Mm-hmm.
We have done some staph measurements in West Hawaii at Puako as part of our studies looking at sewage pollution there. And the counts were pretty low compared to what we see in Hilo. We haven't gone to other locations yet. I have heard people are concerned about that. There are some logistical constraints because we have to get samples back within 6 hours to start processing them. So it is easier for us to do work in Hilo. We would be, we would be interested in pursuing some projects in West Hawaii, but at this time we haven't established any.
If you need contingency funds, I would love to give you some to help out in getting some test samples, increased test samples on the west side. I'd love to work with you guys in the future.
Sure, we would be interested in helping you.
Thank you.
On the staph presence in beach sands graph, it looks like maybe Honolulu has the most.
Yes.
The highest concentrations.
So Honolulu is actually, it has the highest range. It's not significantly different than Bayfront or Richardson's, however. Onekaka and Honolulu were significantly different. And we are looking to investigate that further with Melia throughout this year, looking at maybe if it's the sand type, the composition is different, and also I don't know if she'll be looking at beach goers or any of that, but we're definitely looking at the environmental factors to see if we can pull apart that and see what the difference is from.
Thanks. And are there any ideas that you guys have thought of as far as how to treat staph other than using antibiotics?
As far as treating, we're environmental scientists, so we're not really looking into how to treat it. Our thought has been to get this foundational research and share it with people so that they can make the decision about what is safe for them. They can be more aware of staph as a pathogen and look out for their wounds. If they see things going on, they should go to the doctor immediately. And just sharing that information and sharing that hygiene is important and looking after yourself is important. Not going swimming after heavy rains, all these just golden rules to follow.
Yeah, being raised in Puna and frequently in places like the warm ponds as a kid, yeah, it became standard practice. If you have one small little cut, don't go in the water. Or if you get a cut when you're in the water, to immediately sterilize it. And I contracted staph once, and I was actually able to treat it without antibiotics using this tincture that I had found. And I'll go ahead and share this with you. It was noni root extract, garlic, ginger, cayenne pepper, colloidal silver, lavender, and rosemary extracts, and DMSO, which would make it penetrate into the wound as deep as possible. And you have to put that on like 5 times a day constantly and wash the skin constantly, and shower after the treatment. Shower multiple times throughout the day, and that did work, or at least for me.
That's great. Yeah, that's interesting. Thank you.
Yeah, you're welcome. And because it's definitely a cause for concern that it's becoming antibiotic resistant. That's really scary. Anyway, thanks for the presentation.
Thank you.
My community has been really struggling with this in Kilkaha and Panaeva. Well, Kilkaha especially, because we have the outfall pipe. And then these are where all of our beach parks in Hilo is located, is in my district. So we've been tracking this for a while, but I want to back up a little bit. Your sampling sites up Mauka in the river, at what elevation was that occurring?
It was about 245 meters in elevation.
And did you folks, sorry, it's going to be kind of rapid fire. Did you folks take a look at population as far as residential compared to agricultural within that location site of the sampling site? Like capacity or...
So we didn't look at those things. We just were kind of grabbing the sample to see what the numbers would look like. I know Tracy has done.
There's population information for the Wailuku watershed basin, not for that particular area. We were up by P.E. Honua. One of our students, Tyler Gherkin, as part of his senior thesis project, he's looking at different types of soils from different land uses within the watershed to see how staph concentrations vary. So he's going to be collecting soils from agricultural areas. He's going to look at different types of urban cover, forest. I can't remember all the different ones, but we looked at the land use map for the watershed, and we picked the major categories out. And over the next year, he's going to collect samples from 3 different sites from each category so that we can make a map and see how it might be distributed within the watershed as a first cut. Because Louise's project is really the beginning of trying to understand or identify where it's coming from in the watershed.
Was any consideration given to the type of septic or cesspool systems located to that collection site in the Wailuku area? I just know that some of our communities that were built before septic systems use cesspools. And I'm just wondering if there's a correlation between those high rainfall events that are flushing through our lava systems or our lava tube systems up Mauka into the streams. I was wondering if any consideration was given for that.
I'll start trying to answer this. So we do know that Hilo does have a high concentration of cesspools. It's very hard for us to look at the direct connection between concentrations of staph in the water systems and the cesspool systems, just because we're looking at 24 hours prior to sampling, and we don't exactly know the lag time from seepage from cesspools into our systems. So we would have to figure out kind of what that lag time looks like, and that lag time will be different from the home to the water, for each separate house. So it is kind of a complicated question, but at the beginning of this project, we did recognize that there is a lot of bacteria and pathogens entering into our waters through leakage from cesspools.
A follow-up question. You mentioned during these big storm events, a lot of the water is being pushed out, out of the bay. Has any consideration been given to just the typical circulation within the bay? Because you have a site, bayfront, and which is within the breakwall. And then you have Richardson's and Hornady, which is outside of the breakwall. Was there any considerations given to that?
Well, this is Tracy Wigner again. Louise's study was focused inside the breakwall. So that's where we have most of the information from with regards to water concentrations and rainfall. The other study was part of investigating concentrations at the local beaches. So getting water samples and sand samples. We're not that far into the project yet to link it back to rainfall. So that was one part. The other thing I wanted to address too is linking concentrations in the stream back to cesspools or septic tanks or whatever kind of system homes have is quite challenging. So for example, in Puuko, just to kind of get a sense of how fast the sewage travels from a house to the shoreline, we have to do dye tracer tests. And we didn't do it as part of this project. We do acknowledge that the sewage from the homes could be a potential source. We haven't measured staph in any of the effluent from the cesspools or septic tanks, only from the sewage treatment plant as just a sort of first cut, because sometimes it's very difficult to get into cesspools. A lot of times they are sealed and covered with dirt, and people don't want to dig up their yards to have us come sample. So we acknowledge that we haven't tried to make that link yet. And the stuff outside the breakwall, we haven't taken into consideration the circulation. It was just a first cut of understanding what the conditions are like at the local beaches where a lot of people recreate.